All right, so yesterday you were supposed to finish the extra practice. What I'd like you to do right now is I want you to go through questions 1 through, well, you're supposed to do 1, 3, 4, and 5 yesterday. Okay, so I want you to go through 1, 3, 4, and 5, compare your work with your neighbors. Okay, discuss them there. It's on page 261 of your student journal if you're lost. Okay? Get a couple minutes to do that, please. All right, I'm going to go ahead and put up the answers for number 1, or the answer for number 1. I want you to check your work, and we'll discuss questions. Okay? All right, any questions on number 1? Reality is you could have stopped at 2 pi. I only said go out to 2 pi so you can cover up that last part there. Okay? Good? So stop at 2 pi, you're good to go. If you wanted to keep going just for fun, that's cool. Okay. All right. Numbers 3 and 4. There's 3. Now you will note on number 3 a couple of changes. First, things you want to make notes of. These are the ones I said we're going to be challenging yesterday. First, notice that B is 2 pi. B represents the number of cycles from 0 to 2 pi. And if there are 2 pi cycles occurring between 0 and 2 pi, that means 2 pi is 6.28. So you would actually see 6.28 iterations of this graph, of the sine curve. Okay? Which means I don't actually have this graphed completely. Right? I would actually have to keep going out until I see 6.28 of that curve right there. Okay, 6 1/4 of them. I only see 1, 2, right? 2 and see about 2.5 of them. That's not what would be expected normally, but for the sake of what we're doing here, I'm fine if you only went to there. But make sure that's labeled correctly. Note that when you had on number 1 where you have B as a unit measure without pi, you have pi in the scale. When B is a unit measure or is a measure with pi, pi is not in the scale. Okay? So if you see pi up here with B, then you're not going to see pi down here in your scale. Okay? Because your period length is 2 pi divided by B, and that the pi's will cancel out then. Okay, so 1 period is 1, and you still have to do 2 pi, or 2 pi. You need to graph out to 2 pi normally, meaning you'd have to actually go out to 6.28. Okay? The same thing is going to be the case on number 4. Okay? Number 4 is 3 pi. That means if we were to graph this graph from 0 to 2 pi, if there are 3 pi iterations, 3 pi cycles of it, that's 3 times 3.14, or approximately 9.5 cycles. We would have to see 9.5 cosine curves. Right now we see 1, 2, and half. A little over that. Okay? So the scale. All right. So are there questions on any of the 3 that we've talked about so far? Emma? Right here? Okay, so the scale on the bottom is just figuring out what your period length is. That's why we find period. So 2 pi divided by B, or in this case 2 pi divided by 3 pi, reduces to 2/3. That means after I graph one curve of the cosine, so I get to here, that length right there is 2/3. Okay, so this length is 2/3, which means if I took half of that, that would be 1/3. And half of 1/3 is 1/6. So once I find one length down here, I just start cutting in half until I get to the the smallest unit. And then I can count by that unit. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and so on. Yep. Other questions? Okay. Number 5. Number 5 has a few different shifts here. It says graph the function. We have the 1/2, meaning we should only see, like if we were to graph just the parent function, the parent function here for sine, it would be it would be here, 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 and here. So let me actually draw in the parent function. There's the parent function. But notice that goes out to 4 pi. The period length here is 2 pi. B is 1/2, meaning you're only going to see 1/2. Oops, I missed a corner there. Okay, you're only going to see 1/2 of a cycle of this graph. So right there, you just see that top piece, and let me erase that. Okay, if I was just graphing y equals sine 1/2 theta, that would be that curve right here. That's from 0 to 2 pi. You only see half of a cycle. Okay, so what I've done is I filled up the whole graph. Okay, actually I filled up one complete cycle of it. So I continued it out all the way out to 4 pi, the length of one period. And then from there, you can kind of see the arrows on here. I've shifted my graph pi units to the right and 1 unit up. So this point went over pi and up 1. This point went over pi and up 1. That's represented by the stars there. Okay. And then I just continued the pattern out. Now, once again, you only had to graph to 2 pi, so technically you only needed that much of the graph. This little curve right here. Okay? And so this point would have moved over and up to fill in that. All right, any questions there? Allie? Unless it tells you otherwise. Yep. Okay, you only have to go to 2 pi unless it says otherwise. Please note, like on number 6, I think we mentioned it yesterday, but if there are not x-intercepts, then just label at least what one cycle is, okay, and what you're going up by. Right? And here you do have x-intercepts at 4 pi. If you want to put more labels, that's fine, but make sure that you tell me what the zeros are, and obviously you wouldn't actually get out to 4 pi there, so you'd probably just say, hey, I'm going up by pi. 2 pi's right here. Okay. A couple other things to note are the notes. So you can take a look at page 259 of your student journal. Okay. On page 259, you have a bunch of vocab terms. We talk about amplitude. We've talked about cycle and period. We have not really spent a lot of time talking about phase shift or midline, actually any time on phase shift, but periodic function. I referenced it the first day. Let's see right now, just so that we're clear, a periodic function is any function, anything that repeats itself. So let's pretend like that is one iteration of my function right there. Okay, so another iteration is right there. So that's 1, that's 2, and then another iteration is right there. Okay, any time a graph repeats itself or any time data repeats itself, that is periodic. Okay, your heartbeat, like if you've ever been to the doctor and they've done the EKG on you, you get the heartbeat monitor. That should be periodic. If it's not, then there's generally problems. Okay. Phase shift. A phase shift, you actually dealt with a phase shift yesterday. This is a phase shift. Pi over 2 is a phase shift. It's a shift on your horizontal axis, on your theta axis. That's a phase shift, and that's a phase shift. This has a phase shift of pi over 2 units to the left, and this has a phase shift of pi units to the right. So a phase shift is when it's shifting on the horizontal axis, or the theta axis. And the midline is just what it sounds like. It is the middle line. So if you take your sine or cosine curve, this line is your midline. This line is your midline. That line's your midline. That is your midline. Now, when your graph shifts up, that's now your midline. Okay? And when your graph shifts down, this is your midline. Okay? So it's the line, I guess you could say, that cuts your function in half. That runs horizontally and cuts it in half. Okay? That is the midline. All right. Some other info stuff we've already talked about, just kind of in a different way. Characteristics of the y equals sine x and y equals cosine x on the bottom, page 259. And then on the top of page, or I guess more towards the middle of page 260, they put in the shifts there. Okay? You have that shift. You have your HK shift, your A, and your B here. Okay? All right. So draw the horizontal line y equals kx. That is the midline. They actually, as they go through and graph it, they kind of graph it a bit differently, but you could go ahead and give it a go that way as well if you want. So a lot of times when these are graphed, you kind of sketch in that midline, which helps you to figure out dealing with your amplitude. I kind of use the 0 max, 0 min, 0, and then shift it that way. But, all right. And then up here, talks about amplitude. Okay? Any questions? Okay, good job.